Okay, I guess it's time to start. So please, you can come over here, so you don't have to stand for 40 minutes. So my name is Anton Keks. Probably most of you already know me. I come from a company called Codeborn, and we are agile software development company, and I call myself a software craftsman. So today I'm going to give you an overview of what this functional stuff, which is very hyped nowadays, how is it can be used in your average daily project that you are currently working on. So you can see this as a Java developer's quest into other languages, like a religious quest, where you can search for answers and actually try to apply most of this thinking in your current project or situation. Because all the new programming paradigms, they are, of course, have special languages for them, but you can apply this thinking and these concepts in many other languages, if you see fit. So let's start with a small questionnaire. So which Java do you use currently? Please raise your hands if you use Java 1.8 already in production. It's only 3 of you. So then it's 1.7. It's a lot more people. 1.6. There's still some people. And what about 1.5? Okay, I see there are people laughing. Okay. I know there are some people still using Windows XP, and I can't say that you should not be ashamed of that, and even of that. Okay, if you're still using 1.7, then this now is the last moment when you need to migrate to 1.8 to use all this cool stuff that is available. So, and maybe somebody is not a Java developer? Okay, cool. So let us know. So I want to start with this statement. So the object-oriented programming is dead. Do you agree with me? It's not dead, of course. Many people are using that. All of us are using that, but it's slowly dying. It's 40 years old already, and still actually people don't know how to use it properly. There are still problems which Neil Ford and the previous speaker, Paul Butcher, was talking today, is that the concurrency, there are lots of problems which you face with, and the deep object graphs. There are lots of patterns in object-oriented programming which try to fix it, but still we know that it's not working as we hoped it would work. So object-oriented programming can be called as a model-driven programming. You're trying to model the actual world, but how often classes in your object-oriented programs actually model the real world? There are more. You use more of the services, logators, whatever boilerplate stuff in your programs than the real models of the world, like the model classes. So in my presentation, it is already available online. There will be a link and in the last slide where to see it. There are some links like that you can read to elaborate on the topic. Very good stuff that I selected for you. So there are even some quotes from famous people about object-oriented programming. Like you probably know the Dijkstra. He was the one responsible for getting rid of the go-to statement in structural programming years ago, and he is also saying that object-oriented programming is doesn't match his standards of elegance. So he's a smart guy. Now there is another quote from Joe Armstrong. Joe Armstrong is the creator of Erlang, which is also becoming popular. So the quote says that in object-oriented programming, if you want a banana, you get a gorilla in the jungle together with that. And I think you get what he means. Of course, so the problems of object-oriented programming is the specialty of this operator. It means that every function or method that you have in object-oriented programming, it has an implicit argument of this. which you don't see when you are writing this code, but it's always there. So, but this is the only way to control the function dispatch in object-oriented programming. So you know about polymorphism, right? So this is used, the value of this or the type of this is used to choose the right function to dispatch in case you have it overridden in a subclass. So in a pattern or in functional languages, there are pattern matching instead. And pattern matching is, it provides you the same concept, but it is a lot more powerful because you can control the function dispatch not only on a type of a single parameter, but you can use any parameter, or you can control it much more deeply. Like you can control not only on the type, but on the values of the of other variables inside of the object, like you do in Scala. So, so basically, the object-oriented programming is a subset of functional programming in a way. So, and it means that actually in object-oriented programming, it was thought that you would reuse your code with classes, but it's a quite big chunks for reusing, and it's much harder to reuse these big chunks than to reuse the smaller functions like you do in functional programming. So there is a mutable state in object-oriented programming, of course. If you listen to the previous talk, then you know very well already that is bad. So it's unsafe to return anything from a function that is mutable. There is no implicit caching possible. You need to deal with that by hand. There is no sharing of data, because if somebody changes it, then you will get into trouble with the object that is changing in your hand without you doing anything to it. So there are, of course, the concurrency issues. So, and nowadays, if you think about that, so people use less and less object-oriented features of their object-oriented languages, like Java. So, so code reuse is hard, and actually one proof that it is true is that think of the service-oriented architecture, which is now very popular. It is actually a step away from object-oriented paradigm. It's going back to procedures, procedural programming, because there is no, usually if you call services, there is no polymorphism, there are just plain procedures that you call and then they do something. So, so that is true. There are patterns like dependency injection and aspect-oriented programming that try to solve these problems, but still, I will talk about them later, that they actually making your programs look more functional. So, functional programming. So it's much hyped. We even, on every normal conference we have nowadays not only some talks on functional programming, but even a whole track like we have today. So, and there's lots of interest. So most people still use currently imperative programming languages, but you can already now in your imperative languages, you can start thinking functionally to make your code better. So the question is, if we take functional programming, it's usually it's harder to understand. So I've been teaching programming at the Tallinn Technical University for many years, and I know that imperative programming is more like computers work, is more like people think when they need to automate something. It's easier to understand. So in functional programming, it's different. So it's harder to understand. So, but there are some quotes which I really like. This quote is from 95, I think. It says that program some Java and your C++ will improve. This was when Java was a new language. It was slow because of the virtual machine. Nobody wanted to use it, but everyone were interested. So, and everyone were programming C++ because it was closer to the metal. And it was said that if you try programming Java with garbage collector, with no pointer arithmetic, this kind of stuff, you will write better C++ after that. So it stands for any other language as well now, because Java is aging, is that program some another language and your Java will improve, some more modern language than Java is. So if we look around, then actually functional programming appeared from the academics. It was used in industry many years ago, but it wasn't used very widely until like several years ago. But now it's even in JavaScript. So JavaScript is basically a functional language, and it has very little to do with Java. And most modern languages, even Java 8, they have functional aspects built in. So it makes sense to look at that stuff seriously nowadays. So, and functional programming teaches you very good stuff. It's like being immutable, being stateless, being side effect free. And all these things, they're actually, this is the qualities of the pure functions, but they are also the qualities that you want to have in your well-written code. So if you read any advice on how to program nicely, be it structural, procedural programming, or the object-oriented programming, these things are always the good things that are emphasized. And functional programming just makes them easier to do. So the reasons for that is, as was stated in the previous talk, that the compiler can do more stuff for you if your stuff is stateless, immutable, and so forth, and side effect free. So the compiler can do the parallelism for you. It can do late evaluation for you, like the laziness. It can do memorization, like caching for you, just magically. So you don't need to load your code with that stuff. And if you have less code, it's more readable, it's more productive to write it. So fewer bugs, of course. So in Java, you can emulate functions with static imports. Of course, in Java there is the static stuff. It's considered bad by object-oriented purists, but it's only because it's not object-oriented. So you can write static classes with static functions, like methods which you can statically import and use without the class name in front. So it started looking more like functional programming. If your methods are really these methods are really side effect free and immutable and all this stuff and stateless, then you get functional programming benefits with them, many of them. So when I write Java, actually, I do lots of static imports. So I even have in my IDE a warning is emitted if I don't do that. So if I write alert arrays.asList, then my IDE will highlight it that I need to statically import it to make the code shorter, easier to read. And that's the stuff that I learned from other languages, which are more concise, shorter. And you can write shorter code in Java as well. So, but please don't use static state. So static methods are good, static state is bad. So the stuff should be stateless, so no static fields. So function composition is that also very widely used in functional programming languages. So in Java or in object-oriented paradigm, we have patterns like delegate, or actually decorator and composite. So you can use delegation instead of extending of classes, and it will make it possible to compose add new behavior to your codes at runtime, like the functional programming languages do. So it means reusing through composition instead of extending, because when you use the extend keyword in Java, it's very static. It prevents reusing of your code without of the parent class, and it's a bad thing. if you use the decorator pattern, which is one of my favorite object-oriented patterns, then you can actually reuse classes which are extending stuff by swapping the parents or the ones that you delegate to. So now about more functions. If Java 8, of course, you have this nice little package with lots of functional interfaces, and now we have method references as well. So it's becoming like a more pure programming language, except that it actually modeling functions to objects. Or so in Java, basically, even a method reference, it's an object of which implements one interface with only a single function. So for those who raised your hands after Java 1.8, so you can use stuff like GUAVA, and I have lots of GUAVA stuff in my code, even now when I use Java 8. So GUAVA has lots of interesting helpers, and when I used to program in Java 7, I used a lot of GUAVA to do the collection transformations in a functional way. So it's good stuff, and you can do it right now. So you don't need to wait to upgrade or switch to another language for that. So in one GUAVA example, which does functional composition, is like it has two interfaces. Java 8 has also function and predicate, but it has a lot more, like supplier, provider, and all kind of functional interfaces, which are actually all mostly derived from function. So, for example, predicate is a function that takes some argument and returns a boolean. So it basically makes some decision. So you can even composite, even without the lambdas in Java 8. With GUAVA, you can composite predicates like that, and with other libraries. So there are some helper classes with S at the end, like predicates. In real world, I would, of course, statically import that. I leave it here so that you can see where it's come from. So there is an OR function that takes two predicates and actually combines them into one, making an OR operation between them. So you can, even without lambdas, you can write short code that in a functional way. So you can do operations on your collections with one-liners, instead of using a for loops manually. So, and there are also, if you do testing, and I hope you do, then Hamcrest and Mockito are like the tools that I think nowadays is a commodity. Everyone uses them to do this kind of functional composition with matchers. So for example, you can write with Hamcrest things like that, assert that something equal to anything, and you can now basically this is like a lambda in Java, so it returns you a matcher, and this matcher is applied only when the assert that is called. So it's the delayed evaluation and its matcher, and I can compose this functionally. I can write here not, which is another method which will transform my matcher to a negative matcher, and they are both executed only when the assert that is run. So this is the stuff that you can do in Java since 1.5. So stateless is very, very important in programming. Like nowadays I use Play framework a lot for the next generation internet banking stuff, and I'm not going to talk about that much now, but if you don't know how sessions are handled in Play framework, this is a web framework for Java and Scala nowadays. So it has stateless sessions, and it gives you so many benefits that it will take some time to list them all. So check this out. And of course, if you're writing a stateless code and stateless functions, it's so much easier to test. So you just, it's very easy, you don't need to mock anything. You just provide the inputs, get the outputs in your code, and don't need to deal with mocking of the state to test your code. It's much easier to not skip testing your code as well, if it's easy to test. So, and data. Rich Hickey, the creator of Clojure, is, I don't remember the exact quotes, but he often elaborates that actually data is more important than the representation. It meaning that you don't need to put your data into a graph, a complex graph of objects. You just need the data and operate on it as a data, like as a simple data, like list or map. And if the language has lots of built-in support for operating efficiently with lists and maps, like Clojure and like Scala and like Java 8, then you can actually, you don't need to create classes for most things. So it means that your code should represent computation, not try to represent the world, which is much harder, and people usually fail at that, even if they initially it seems that it's succeeding. So, breaking data into objects in your code is always very arbitrary. So if you take two programmers, they will model the world differently in their object-oriented code, and it will be hard to actually work with both of them. If you have two different frameworks doing the same things, they usually will not be interoperable in object-oriented world, because they modeled the world differently. So in functional programming, tuple is very often mentioned and used as like a temporary holder of the data, like for a function which needs to return multiple values. So in Java there is a class called tuple, but you can actually emulate that very easily with asList, which is a very good function which existed since Java 1.2, and starting from Java 1.5, which added var args and added static imports, it became a very versatile tool that you can use actually anywhere in your program to build lists, collections, empty lists, and whatever. You can use it for many things, and you can use it to conveniently return more data from your function if you need it in Java. So there's also a good article on that. So with collections in functional programming, collections are first-class citizens. Like Neil Ford mentioned today, that in Clojure you usually represent XML as a map, and not as a very awkward DOM object model, document object model, and Clojure can handle maps very efficiently, and that's why it's better to represent your data in many cases as native collections of your language than not on some specifically made structures which are not very reusable, like document object model. So there are three Lispy workhorses usually in functional programming languages, which are map, reduce, and filter, which they very often have different names in different languages, but in Java 8 they used this convention. It's and you can use them very efficiently to transform and operate on your collections without doing the for loops manually, and it gives you the parallelism and gives you better performance and late evaluation, laziness, and everything like that at no cost, like it was shown by the previous talk. So. Yeah, and it's available in Java 8, of course, and you can use it with GUAVA, for example, in earlier Javas. So, and immutables. Immutables actually were a part of Java API since 1.0. If you notice, string is thankfully immutable, and many other core objects in Java are actually immutable. So, what about your classes? So Java has actually propagated immutability from the very start, but it seems that developers didn't pick it up. But you can do that, and you get lots more benefits of functional programming in your code. It's just too easy in object-oriented programming to create mutable objects, and that is the problem. But you don't have to do mutable objects. You can do immutable. I'm going to largely skip this parallelism stuff because the previous speaker talked about it quite nicely. So synchronization, of course, is hard, and you don't need it if there is no shared state or if the stuff is immutable. So in different programming languages, or modern programming languages, there are different solutions to that. Like in closures, there are these agents. In Scala and Actka, there are actors. In Erlang, they are called processes. In Dart, there's isolates. And all these names, they actually do use the same concept. No shared data between parallel execution threads. And they communicate with each other using message passing. It's like the asynchronous message passing, which doesn't use shared state, and that's why it's safe to use it in multi-threaded environment. Nowadays, it's very important because we have lots of cores in our processors. We have lots of concurrency and parallelism in our applications because we are doing mostly web kind of applications, distributed applications nowadays. So these things, if you follow this principle in Java, and you can even use the Akka and some libraries in Java as well, they will actually save you a lot of stuff. Or if you are writing your threads manually in Java, just keep in mind that no shared data, and you will be mostly safe. You don't have to do all this complex stuff to synchronize your code. So, and JavaScript is a funny guy to teach you something about concurrency, is that you can actually emulate concurrency, or it can look like concurrent, but using the asynchronous APIs. So JavaScript is by definition single-threaded, and if you write using nodes, for example, in JavaScript server-side apps, at first you can't believe that you can write a serious app using one single thread, but when you do it and you see that it performs and it can serve lots of concurrent users, you realize that actually that concurrency should or can be done in completely different ways, which is helpful to know when you're writing your Java code. So about JavaScript more specifically, it's widely used. All Java developers, most Java developers, I think they also are JavaScript developers, so we can learn a lot from JavaScript. So it has almost nothing in common with Java besides the name. So in JavaScript, JSON is means that data is a first-class citizen. It's like in functional programming. You don't create classes, you just pass your data as a map, basically. Then there is this asynchronous stuff that actually can teach you a lot if you try it. In Java, you can try Java Neo, which also supports asynchronous stuff. And the Nginx, the very popular web server nowadays, also is asynchronous and web server, which actually outperforms the threaded models of Apache. So and it's getting more popularity. It means that in your code you can also go the asynchronous way to gain more performance. So Play Framework is a good example. They use a lot of asynchronous stuff the same way as Nginx does. So it can use asynchronous I/O, and you can, with a small amount of threads like Node.js, you can support like thousands of concurrent users. I actually done that, and our internet banks that we are doing, they actually run fine on a single server. Usually it's two for redundancy reasons, but they usually a single server can handle the whole load that I have seen in quite big banks with millions of customers. So Of course, in JavaScript it brings code later, but there are some nice patterns like promises, and promises are also available in Java. So reactive programming is also a very interesting concept to think of when you're developing, and in JavaScript world it's very popular nowadays. It's to define it very quickly and easily, it's like a spreadsheet. You have all your data, you change something in one place, and all the other dependent cells, they change according to that. So you don't need to write some code that synchronizes the cells in a spreadsheet, because spreadsheet does that automatically. So when you're doing more complex programming, it's very important to think about maybe you can do it in a reactive way. So other example is the triggers in relational databases. So you can make that inserting of new data or updating will update the other parts of the database automatically. So you don't need to code that by hand every time you insert a new line to your database. So in JavaScript world, there are frameworks for that, like Angular, which is very popular, and the older like Knockout and in some case Backbone. So these guys teach you how to do reactive programming in JavaScript, and you can apply similar principles in your Java programs as well, which is a lot less error prone. So it works just like that. It will do this cycle for you automatically. In Java, you can emulate reactive programming with the observer pattern and the kinds, and there are also some frameworks for that. So jQuery specifically, which revolutionized the web development, is we can also learn a lot from that. So it's very much criticized for performance, for bloatness, and whatever nowadays, but it does several things very well. So it has a short, simple syntax like that. You can do complex stuff with only very few characters. Everything is a collection, which is my favorite part about jQuery, is that and it does implicit iterations for you and chaining. So look at this line of code. We select all anchor elements from a DOM page, and we don't care here, did we get only 1, 0, or many of them. So that's the good thing, the best thing about jQuery. Then we can navigate it by chaining. We can ask for a parent. We get all the parents. If we have many of them, we can add a class to all of them. We can then go back and to the anchor element, and then, for example, put an event handler, event listener to all of them. Again, we don't care here whether we have 0, 1, or many of these. And imagine that doing that in Java, it's a nightmare. You need to check manually for all the cases. In jQuery, you don't care, and it produces much simpler code. You can do that in your code as well when you're designing your own API. So think about that. So in Java, actually, we have one library which is actually maintained by one of my colleagues from Codeborn. Is Selenide, is a UI testing framework that uses the jQuery-like syntax in Java, and it works perfectly. So you can do these kind of things when you're testing your web pages automatically, and it also follows the stuff for assertions, like in a DSL, like they do in RSpec or some other testing frameworks. And of course, Java had its first ever chaining class, which was a string buffer, which also have this chaining API, which you can use when you're designing your own, and any other builder pattern-based API out there. So NULLS is a very bad thing in Java that it inherited from C++. You get these null pointer exceptions all the time, and in other languages there are very good stuff about that. And for example, in Objective-C, you never get null pointer exception because method calls are called message passing, and messages, they actually, if nobody listens to this message, then not a big deal. A lot more convenient to write code. Then in Groovy, there are the question mark operators, which help you very easily to avoid null pointer exceptions. And there are some languages like Vala in Kotlin, which try to check for nullability at the compile time, so that your code will not compile unless you have a null-safe code. So in Scala, there's very explicit null handling like option that you need to ask from option, does it have the value or not? So, and SQL is just bad, because if you compare anything with null, you get always the negative result, and even null equals null is false. So, which is creates, you need to write lots of bloated stuff in your selectors. So, in Java, usually people use things like that. They put the object in front, and null can be as a parameter, so you will not get null pointer exception. Then in Java 7 there are objects class which helps you. It has some helper methods to avoid nulls. And in GUAVA there are very nice helper methods like first non-null. You can just pass it several arguments and it will select the one that is not null for you. So you can write more concise code with less ifs. And in Java 8 there is also an optional, and in GUAVA as well. Like in Scala, you can use it already today to fight nulls. And there is an interesting use of, or trying to use of the annotation like nullable and non-null in Java. So if you provided that you annotate your code with that, then the compilator can find your mistakes. So if you're trying to dereference a nullable value, it will warn you that it can be nullable and you need to do the null check manually. So clearly in Java you need to choose some good way to deal with nulls to help you. So dependency injection is very good, one of my favorite object-oriented patterns that actually helps you when object-oriented programming gets messy, when you have deeply nested object graphs. So what it actually does, it resolves dependencies of your classes at runtime. It means that your code is becoming more dynamic programming. So this is something that you can learn from dynamic languages like Ruby, Python, and whatever else. And dependency injection, that also is sort of functional. It brings functional aspects to your object-oriented world. So injector that actually, or the container of the dependency injection, it can actually do high-level optimizations of your code the same way like functional languages do. So it can is free because you just define what are the dependencies are, but you don't specify how are they obtained. Then injector can actually decide on the best way to do that. So it can do caching automatically, like memoization in programming, in functional programming. It can do pooling of objects. It can do reordering of creation of objects, or it can even parallelize it. If creation of some objects takes time, it can create other objects in parallel, and you, in your code, you don't care. And that's clearly the benefits of functional programming in your object-oriented world, if you use dependency injection, of course. But it means that there better be no side effects in your during objects construction, because if dependency injector will change the order, then you can get some strange surprises. Google Choose, good tool for that. You can check it later, how to use it. Very concise and easy way to do dependency injection in Java. And it even does the aspect-oriented programming look not so bad in Java. You just bind to any method annotated with cache annotation, for example, and you intercept it and do caching, for example. So you can do memoization and this kind of stuff with Choose with your existing Java code very easily. So it was much hyped before. It's quite difficult and crazy topic. It had this aspect J had a terrible syntax, and but you can still use object choice for that to do it very cleanly and easily for you. Now, unfortunately, I need to finish, so I will just skip some slides and check GUAVA. It has this fluent iterable stuff that does the collection transformations using chaining even in Java 1.7, very easy to do. And think of functional programming stuff is like design patterns in object-oriented or Java world. So you just can bring more of dynamic and functional stuff in your programs using that. And the most important thing, after all, is the simplicity and clean code that some of these patterns and approaches that you learn from other languages bring to you. So when you program in other languages, if you program some Groovy or Ruby or Scala or Clojure, you can it can dramatically improve your Java code in day-to-day programming. So you can go and try some stuff as a hobby, and then you see that you are a much better programmer after that. And last but not least is that other languages can also, and other platforms can learn some things from Java. What's good about Java is that it's cross-platform, unlike some stuff like Objective-C or .NET. It's supported Unicode since '95. It's unlike Ruby or Python or some these non-JVM based languages which still have problems with character encodings. It's very performant. The JVM is actually, it's often said that JVM will outlive the Java programming language. There are now Clojure and Scala and other languages on JVM. And the most important thing is backward compatibility. This is the thing that we don't have in Scala, unfortunately. So Scala, even the previously compiled Scala library cannot be used with the newer version of Scala, and that's a disaster. And this is something that Java does extremely well that other languages and platforms could follow. So thank you so much, and I hope your programming will improve if you start digging into other paradigms and programming languages.